All right, we're going to start by looking at 9-7 in the back. A couple of problems, just make sure you guys are in the right place. Number 19 is an obvious one. Give you a moment to find it. It's log base 6 of xy squared over square root of z. I'm asked to expand this. So to expand it, let's start putting together the pieces. I would look at it and go, well, division inside would be subtraction outside, so I'm going to go ahead and do that. At the same time, we remember that square roots are the root of all evil. We're going to get rid of those. I'm going to separate this some more. I go log base 6 of x plus log base 6 of y squared minus log base 6 of z to the 1/2 power. And I haven't expanded this enough because I got powers I can throw in front. So I got log base 6 of x plus 2 log base 6 of y minus 1/2 log base 6 of z, and I'm officially done with that expansion. And it's a nasty one. Everybody got it? All right. I'm going to also look at number 25, because number 25's got a weird connotation to it. So let's look at 25. 25 was 3 ln x plus 1 minus 2 ln of y plus ln of y plus ln of 2. Agreed? So I would throw that inside. I got ln of x plus 1 to the third minus 2 ln of y. Oops. Now, actually, there's two things you can do here. I could throw the negative 2 in, or I could throw just the 2 in. Probably most of you just threw the 2 in, so I'll leave it like that. But remember, a negative exponent is going to put on the bottom, or dividing puts it on the bottom. So it doesn't matter. Either way you want to go. You got it. Okay, plus ln of 2. So then I would look at this and go, oh, are you kidding me? But I'm not kidding you. So we have to do this big foiling thing. So we go x squared plus 2x plus 1 times x plus 1. Oh, yeah, enjoying the ride. Condensing as best I can. Subtraction means division. Addition means multiplication. Addition means multiplication. Oh, yeah. So then, ln, I got x to the third plus 2x squared plus x squared plus 2x plus 1 times 2. What happened to the y? Y cancels out with one of the y's at the bottom. I'll put it on the bottom. ln, absolute value. Sorry, no absolute value at all. Think of something else altogether different. Let's not talk about that right now. 3x plus 1. I need to change this by plugging in a 6, and a 2 all over y. And that is theoretically condensing it. Ouch. Doesn't look very condensed to me, does it? Switch to 9-8, the back. We need to talk about change of base part 2. Change of base part 2, it says on the back, so go ahead and go there. I'll remind you what our problem was. We started off with, I wanted $1 million, and I wanted to put it $1,000, and I found a magical bank, which these days does not exist, which is going to give me 1% interest compounded monthly. I don't even know how many months it would take to do it. And so we simplified this a little bit. We said 1.01 to the t is 1 million. And then we divided both sides by 1,000. And then we ran into this thing where we get, oh, crud, can't do this. Well, now we can do the next step, right? We know how to do the next step. The next step would be log base 1.01 of 1,000 equals t. And now I get to cry again because I do not know what log base 101 is. Fear not. Some of your calculators do have this button. I'm going to totally ignore the fact they do because that doesn't help us at all. We want to change the base anyways, so we're going to do it anyway. So I'm going to divert. I'm going to say I still don't know how to make my $1 million, but while I'm thinking about it, let me come up with a brand new idea, and that is log base b of a is equal to. So in order to do this problem, I'm going to go ahead and set it equal to x, because x is fun. And then I'm going to do what we always do. A equals b to the x. With me so far? That's just done because why? Because that's what we do with logs, right? That's the definition of a log. So far, so good. And then I'm going to log both sides. Base whatever I want. Probably base 10 or base E, right? Either one would work really well. Now we just learned that if you have a power, you can throw it out in front. Agreed? And if I divide both sides by log base C of B, I get log base C of A over log base, can't even write it, hold on, I got this. Log base C of B equals X. Do you remember what X is equal to? Aha, log base B of A. This is called the change of base formula. Written out, you'd normally write it this way, so I'm going to go ahead and do that. Log base C of A over log base C of B. And so you need to absolutely have that down because that is incredibly powerful. It means that I don't care. I don't need a special button for log base 1.01 because I can do it in any base. I already got 2 base buttons on my calculator. Why do I want more? Just confusing. How does this formula work? Let's do it. I'm now going to go back. I'm going to finally figure out how much time it would take to have, how many months would I have my $1 million? So I go and approach this problem. I'll use change of base. Now I can use log base 10 or log base N or E or anything I want to. I'm going to go ahead and do log base 10. Remember, look what I didn't write down. Didn't write down the base 10, did I? But I should. But one of the notations is we don't. So now I'm just get out my calculator. I'm going to hit log of 1,000, which by the way is 3. Shouldn't need a calculator for that, by the way. To what power 10 do we need to raise it to make 1,000? That would be 3. I do need it for the second one though, 1.01, and I get 0.004321373373783, etc. equals T. So now you go 3 divided by that ugly answer, and I get that it's only going to take me 694 months. Which isn't that bad if you think about it. That's only 57 years. So if you're my age, you'd be dead before you hit your $1 million. But if you're your age, figure out somebody could give you 12% interest compounded monthly, which did exist back in the 70s. It would only take you 58 years, and you'd be a millionaire for putting $1,000 in, which is surprisingly good. Again, best kind of interest you can get now is nowhere near 12%, so the calculation still dooms you. But fun and something we can do. So let's estimate log base 3 of 8. Log base 3 of 8 to 3 decimal places. Have a whack. Have a whack. 1 Mississippi, 2 Mississippi. Now look at the little clock at the bottom. Listen to some Dodger game while I'm waiting. 1-1 game, it's close.
4-1, Cardinals on top.
Ah! Cardinals are ahead now, 4-1. What happened? No! Well, not listen to that game anymore. All right, we're back. Ready? I'm going to go log base, let's go base 10 over log base 10 of 3, and I get, just put in my calculator, log of 8.903089987 divided by log of 3, 0.47712125547. This is too confusing, so I'm just going to go ahead and do log of 8 divided by log of 3, and I get 1.89, should have around it 3 decimal places, 1.893. Which makes some sense because 3 to the 2 would be 9. It should be pretty close to that, right? Legit. All right, with that in mind, you should be able to tackle the first problem on 9-9. We'll go ahead and pause it right now, and when I'm done pausing it, then we will, when you guys are done with number 1, we'll do that. All right, here we go. Number 1, log base 6 of 832 equals log of 832 over log of 6. Throw that in my calculator. Log 832 divided by log of 6, and I get a lovely 3.752. Doesn't say which round to. I should tell you which round to, so let's go 3 and call it a day. Let me try number 4 now. Again, we'll pause it. Number 4 says they specifically don't want you to use log base 10. They want to use log base E, or ln. See how that changes how hard the problem actually is. It doesn't. Okay, so that was a pause, but it wasn't a very clear pause, so hopefully we paused. You didn't pause now. Here we go. Log base 7 of 94 can be rewritten as ln of 94 over ln of 7. Just do ln of 94 divided by ln of 7, and I get 2.335. And I'm done with that one. That's weird. Let me try number 7. Number 7. And again, we'll want another pause here, so I'm going to pause in 3, 2, 1. Okay, pause should be virtually over. Here we go. 6 to the x equals 42. How the heck am I going to do this? This is one where it gets really fun, because there is, no kidding, probably 18 ways to do this problem. Let's do the 2 obvious ones. Obvious way number 1, the traditional way to do the problem, is to go log base 6 of 42 equals x. So therefore, we would do log of 42 divided by log of 6 equals x. And I would go put in my calculator log of 42 divided by log of 6, and I would get a lovely x equals 2.086. That is the traditional approach, and it works beautifully. Or I can go really crazy. I can go, wait, I'm going to pick my own log. I'm going to go log of 6 to the x equals log of 42. I'm just going to log it. I'm going to throw the x out in front. Yeah. Once I do that, I'm going to go ahead and move the log, divide both sides. I'll turn log 6 into a number. What's log of 6? 0.77815 equals log of 42. 1.62325. And then I divide, and I get 2.086. Oh, look. Which way is the right way to do it? I don't care. Have fun. Do ln if you'd like. Move things around if you'd like. You can do it lots of ways. Okay? Those are the 2 probably best ways, most practical ways to do it. Now, the rest of the worksheet has a bunch of inequalities on it. Can you turn those all into equal signs? As long as you promise that later on you'll remember just to plug in a 0 to see if they work. That's what we want, right? Plug in a 0, see where it works. Okay, so we're not going to bother that. Just make it equals and do the rest of the problems. Should be easy peasy lemon squeezy for students like you. Enjoy, do the whole worksheet. Until next time, I'll talk to you later.